This is Gary LaRue of Microwave Journal. I'm at the International Microwave Symposium in Atlanta, where I'm talking with John Ekis of Rogers Corporation. John, what are your responsibilities at Rogers?
So recently I've been hired as the Market Segment Director for our Aerospace and Defense business unit. We're really trying to differentiate and define how we can structure advanced materials technologies that Rogers has into the A&D, benefit the warfighter, benefit the defense community.
So as you listen to your customers, what trends are you seeing in the aerospace and defense market that are being flowed down to you, and what kind of effect are they having on the requirements for materials?
Sure. It's great questions. We were just chatting about this a little earlier today. You know, some of the electronic warfare sector, really broadband, high instantaneous bandwidth, kind of moderate to high power structures really starts to challenge some of the material designs that we see today. If you look at like a radar, a classic radar band, it's narrow band, you know, low instantaneous bandwidth. Some of these structures here easily solved, stable temperature ranges, but you get into an EW spectrum that's covering, you know, 500 megahertz to 18 gigahertz,
right.
And it's really putting a challenge on the designs themselves. Do we have to break it up into multi-designs? How do we have one laminate material system that covers that entire frequency range? So there's some really challenging areas that I think that are going to be addressable in the future with some new material technology and new material designs.
So we're seeing a lot of activity at millimeter wave on the commercial side. Are you seeing that in the defense world as well?
Yeah, the millimeter wave stuff for me personally is pretty exciting. I'm looking at a lot of the crossover technologies, trying to adapt what we're seeing in especially the ADAS market, the automotive systems that are out there today, the 77 gigahertz radar systems. If you could take that technology, for example, bring it down into Ka band, Ku band, different frequency sectors, it's going to open up some really dynamic applications for everything from vehicle protection systems to automated driving. It's really amazing that, you know, we tend to look at the drone market or the UAV market and we think of airborne systems. That technology is coming the whole way down to the ground vehicle. We're starting to see automotive technologies moving into autonomous ground vehicles, systems that are going to have to be able to communicate with each other, have a whole different functionality, have to be able to communicate soldier to soldier, soldier to asset, battlefield command, going up to SATCOM, going up to data links. It's incredible how this whole thing is changing right now. It's really, I think it's an exploding market, no pun intended, but you know, we really like to see this type of activity where we can find crossover, bring a 77 gigahertz down to a 24 gigahertz, protect a helicopter, as an example. Knock down a missile that's coming in to take out an APV, those types of things that we can deal with. In a corollary, the 5G market, if you've been following the A&D sector, is really starting to drive and capture that communications technology for command control infrastructure. Right. So they take that same 5G technology that they've been looking at for our cell phones and move that down into how do we make a more efficient, more demonstrable command system for the battlefield environment.
So given the complexity of all these different applications, commercial, military, does it make your job easier or harder from a materials standpoint?
As a dreamer, it makes it a lot harder, right? So there are a tremendous amount of opportunities, and really the challenge in the A&D sector is trying to figure out the opportunities that are going to be the near-term focus, things that we can develop right now. You know, we've come out recently with a lot of new materials and advancements on some of our materials that are helping our A&D community. We can talk about in a few minutes. But the challenges are the industry's moving much faster than I've seen it move in the past 20-some years. And the adoption rates, and I think that we're finally breaking away from the classic, very conservative, we've built it with this material set because we've always built it with this material set. And now with some of the advanced R&D technologies and R&D efforts, especially with the Biden administration throwing out more funding for R&D than has ever been put out into the defense budget, that's going to start driving a lot of innovation, and I hope some of the adoption rates are going to be coming up faster. There's a lot out there. We just have to figure out how to make these guys comfortable with the new technologies and comfortable with some of the new material sets to drive what they need to solve.
So speaking of speed, we're seeing a lot of activity in the commercial space sector, the so-called new space, particularly with these low Earth orbit satellite constellations for broadband. How is that spilling over into the military side, or is it?
Yeah, no, it definitely is. Several ways, Gary. The obvious one, the first impact is we're looking at taking that communication structure and using that, especially with the 5G, that we're starting to see a lot of the LEO applications generating out of 5G. They're going to start piggybacking on that communications link, right? So we're going to see that into the A&D sector. It's probably going to be unique frequencies. You know how the frequency allocations are always given out. You'll have a section for the military, you'll have a section for some of the other technologies. So I think we're going to see that moving into more adoption of the 5G for the, we just mentioned, for the communication systems. But where I really see kind of the generation on this is, especially in ballistic missile defense and especially in hypersonics sensitivities, as we see the hypersonics threat becoming larger and larger, it's going to have to rely on some type of layered defense. Before we would sit there and we'd look at, an OFIR or some type of infrared detector sitting on a geo satellite that was watching for a ballistic launch, and they'd see the big heat signature and the big plume, and they say, there's where it's coming from. Yeah. Now with hypersonics, the temperatures are a lot lower, speeds are a lot higher, and they're really struggling to figure out how do we defend ourselves against that. So I think that a layered approach with the SATCOM market going from a GEO down to a LEO, and then there's going to be this inner layer, structured layer of satellites and SATCOM systems that are really going to help, especially for our ballistic missile defense. So I think that's where we're going to start seeing a lot of convergence in that.
Great insight. Thanks for sharing that. Well, we're here at IMS. First time we've been out in a couple of years. What is Rogers featuring at the show?
So we've got a couple of things. One of the things is on the panel over here that maybe you can look at a little bit later. We have working on some magnetodielectric materials, and it's really the purpose of it's for miniaturizing antennas. So it's called our Magtrex 555, and it's a system that is going to allow you to generate some very low profile, much smaller aperture antennas. Now you can think of a ground-based vehicle, for example, right? It has to have a SATCOM communication link. The last thing that guy wants to have is an antenna that's sitting up there, floating around, everybody can see the darn thing, and it gets knocked off by a tree limb. Right? So conformal, low-profile antennas, things that are going to be better SATCOM communications, better GPS and GNSS locating systems. So that's exciting. We've been doing a lot of work on our Magtrex line and starting to generate a lot of interest in the past couple of years. I talked a couple of months ago with the IPC group, and we were talking about our speed wave material. We talked about speed a little bit earlier. Our speed wave materials are really enabling us to generate thinner, higher laminate structures with some of our advanced materials, some of the high frequency solutions we have. So really going up with blind microvias, higher layer count structures, being able to impact more into small for size, weight, and performance reduction swap in the A&D market. We've really been looking at that as being a technology that's going to help to revolutionize the fabricators and the circuit board designers in some of that market. Yes, we talked about our speed wave recently. Some of the stuff that we're working on coming out real soon is looking at some lower copper thicknesses, thinner dielectric layers, good performance dielectric layers. And again, that's all going to help as you start building your stacks up, especially in high density circuits with thick copper. You start getting a lot of conformal aspects that we have to deal with. And I think a lot of these new materials are going to address some of those problems.
Well, John, thank you for talking with us. It sounds like despite the pandemic, you've been very busy, as the whole team has, and have a lot of new things coming to the market.
We're excited. It's really good to see you guys again, and look forward to next year.
Great.
All right.
From the IMS in Atlanta, thanks for watching.